Number 5 has 4 FTC problems, FTC Part 1. So we're going to evaluate these definite integrals using the fundamental theorem of calculus. So 6x squared integrated is going to give us x cubed, and then 6 divided by 3 would be 2, so we get 2x cubed plus x to the 4th, and we are evaluating that from 0 until 2. So what do we get? We have 2 times 2 cubed plus 2 to the 4th. Okay, that's the first part. We plug in 2 to our antiderivative. And then we're going to subtract 2 times 0 cubed plus 0 to the 4th. And we know this is just going to end up being 0. So we don't really even have to write that if we can see it that in advance, that when we plug in 0, we're just going to get 0. So then we have 2 times 2 cubed. 2 cubed is 8 times 2 is 16. Plus 2 to the 4th is also 16. So our final answer is 32. All right, that's part A. Part B is a trig example, integral from pi over 6 to pi over 2 of 4 cosine x. I like to draw this chart. This is our derivative chart. So derivative of sine is cosine, derivative of cosine, negative cosine back to sine. Because when we're integrating, we're just going to go backwards, right? So here we have 4 cosines. So we're dealing with cosine. And the integral of cosine, we're going to go backwards on this chart. It's just going to give us sine. So this is 4 sine x evaluated from pi over 6 to pi over 2. So what is that going to give us? It's going to give us 4 sine pi over 2 minus 4 sine pi over 6. Okay, I'm going to think about my circle. Okay, on my circle, sine of pi over 2, sine is y, so pi over 2 is here, so sine of pi over 2 is going to be 1. So I get 4 times 1 minus 4 times sine of pi over 6 is 1/2. So then I get 4 minus 2, which is going to give me a final answer of 2. All right, moving on to part C. Just have to remember my trig derivatives. The derivative of tangent is secant squared, so the integral of secant squared is going to give me tangent. And that's going to go from 0 to pi over 6. So I have tangent of pi over 6 minus tangent of 0. Okay, so what do we have? This is sine of pi over 6 divided by cosine of pi over 6. Okay, minus sine of 0 divided by cosine of 0. All right, so we have 1/2 divided by root 3 over 2. And that's minus, sine of 0 is 0 over 1, so 0 over 1 is just going to be 0. And then this will give us 1/2 times 2 over root 3, which is 1 over root 3, which is root 3 over 3. You don't have to do it this way. If you can just remember the value of tangent of pi over 6, then you can just do that. But this is how you can figure it out if you don't have your tangent values memorized. Okay, so we have root 3 over 3 minus 0 is going to give us a final answer of root 3 over 3. Okay, moving on to part D. Integral from 1 to 3 of 3x squared minus 4x. So reverse power rule, we get x cubed minus 2x squared evaluated from 1 to 3. So we have 3 cubed minus 2 times 3 squared. And then we have 1 cubed minus 2 times 1 squared. 3 cubed is 27. 2 times 3 squared is 18. That's going to give us 9. 1 cubed is 1 minus 2 times 1 squared is 2. That's going to give us negative 1. And we know we need to subtract these values, so we get 9 minus negative 1, which is going to give us a final answer of 10. All right, sometimes I like to do these calculations separately so that I don't mess up the signs. Plug in 3 separately, find the answer. Plug in 1 separately, find the answer, then subtract them. But you can do it however works best for you, as long as you can arrive at this final answer without messing up one of the signs.